Hi guys, this is NinjaGreg. I'm going to walk you through how I approach working on the revisiting puzzles. As we go along, I'll describe what I'm doing. Now, the first thing I do is get set up. I go to the undo interface, which gives you this menu, and I hit tracks. You can see I've done this puzzle before, so a track is a parallel part of execution. So you can have multiple clients working on the same puzzle, but each client needs to work on a different track, otherwise they interfere with each other. So let's just make a new track here. Let's do a recording track. Create. So we're all set. I started from the default, which is where the puzzle starts. I try not to touch that one and just work on a track other than that. So then what I do is I look at my behavior options. I usually start on low. I found that it works best if you start these things on low and then work from there, get as many points as you can, and then from there you can bump the wiggle power up. So first thing I usually do on these puzzles is take a look at them. It looks like these 4 sheets may have started together, and this may be a set of sheets that wants to be together. This is a loop that kind of connects these two, a little bit of a 3-segment helix. There is a small helix there and a small helix here, so it looks pretty straightforward. The first thing I usually do is try to relax it from where it's been put as the initial starting position. So let's do a shake. And what I do is shake until the score stops moving. As you can see, that's pretty quick with these small puzzles here. So there, it stopped moving. And then I just do a wiggle. Now, wiggle, that gets you a lot of points. You can see we're all the way up to 9,000 points. The next thing we do is we can, since we looked at it and said these may look like they want to be together, let's see how we would fit them together. Let's see, I should set my view options to, let's go preset options. Let's do protein folding. But what I like to do is I don't show clashes or voids necessarily, or this is not a symmetric. I hate pulsing when working. Show the bondable H. And show the bondable atoms there. That's the important one. Okay, so now you can see these little red and blue guys here along the sheet. These give you, you can see there, that's an acceptor. That's a donor. So what you want to do is pair up the acceptors with the appropriate donor. It looks like this one has the blue one right there. We probably want to pair that up with this red one here. So let's try putting some bands on. What I do is I just go through, put bands between segments that want to be next to each other like this. I put some on the ones that are connected that are currently working with that in order to keep them together. So let's do that. And then let's see, there are some more over here. These look like they're already together and they're all happy. So here we can see there's a red and a blue. So let's just put these together. Maybe we can get a little more togetherness here with this part. Okay, now we've got all that. Let's try wiggling some more. We're at 91.52. Now you can see here in the middle, We've got a couple of H bonds forming. Oh, there's a couple more. I don't know if we'll get one here. This guy's kind of twisted. If it looks like you're having a little trouble, you can look at it and say, okay, let's add another band on this guy, and maybe put the next ones together. The next segments. This one, so this one goes to here. Okay, so no, it doesn't look like he's going to get it. Okay, so that may be due to this guy being bent over so much. So let's try a shake. You can see I'm using the keyboard here, the W and the S keys, to do the wiggles and the shakes. So the shake gets us up to 9,400. Now we go back and do a wiggle, and 9,400. Okay, that looks like about what we're going to get. So let's remove all the bands. That's the R key, and wiggle again and see where we get. So you can see the bands tend to reduce the score a little bit, and when you free the protein, it'll point up a little bit for you. So there's that. And then the next thing, I'm a great believer in recipes. So I have a cookbook with lots and lots of recipes in it. Ones that I like to run next after I've done the wiggles and shakes and wiggles and shakes. Let's do another wiggle, make sure we don't get any more points, another shake. Make sure we don't get any more points. Okay. So then there's one called Cut and Wiggle Everything. What I recommend, if you haven't used recipes before, or you want to figure out what they do, you can either look at the code if you're a coder, or you can just run it kind of with the defaults and see what it does. In this case, what this one does, here you set the step size to 3. So what it's going to do is count off starting from the first segment there, segment 1. It's going to count off 3 and then cut, and then 1, 2, 3, and then cut, and then put in a cut. And then it's going to wiggle while all those are cut. So what that does is essentially free up the 3 to operate as an independent unit, independent of the rest of the protein. And then you heal the cuts or delete the cuts, and it'll wiggle again. While it's doing that, as soon as it does the cuts, it changes the clashing importance down to 0.3 or whatever you set it to here, and then it wiggles it until it stops moving in the points, and then it moves it back up to the high clashing importance and wiggles, and then it you see where you get. So let's try running it and just watch it as it goes. Oops, see there. There's one cut, there's another cut, and you can see there's 3 segments, 1, 2, 3, in each of the little groups. And so, and you can see here, oops, where's the, no, it doesn't show you that. Okay, not that. Let's bring this guy up. You can see it's at 0.3. Now it moved it up to 1. And we've moved it up to 9601 already. Always look at the output of the recipe. Let's move that up here to keep it out of the way. So what it did was show us this new score after it went through one sequence of that, and then the highest score that it's been able to achieve so far. Then what it did was say, okay, now let's go, we're going to do it every 3, but we're going to skip 1 and then start here. So our group of 3 starts there and goes on through the protein, and it does it again, the sequence where it does the cuts, wiggle at a low CI, wiggle at a high CI, restore the cuts or delete the cuts, wiggle at a low CI, wiggle at a high CI. And you can see now we went from 9601 to 9710. So we just wait, watching it while we can watch it while it goes. One of the things I like to do, let me bring my view up. Viewing this, I always show all the side chains. It's a little slower and it looks a little more busy, but you can see, you know, if you're having trouble getting something to move together, you can see, oh well, this guy's interfering with this guy, or this guy's pushing this guy away, you know, that kind of thing. So I like to have them all together like that. And as you can see, maybe the reason we were having trouble getting that blue to talk to that red was that indeed this guy was pushing away from that. These are fairly strong influences on the side chains, and so you can see that he went from there. Okay, so now we look at the output some more, and now we're up to 9812. You can see that doesn't take very long at all. Okay, so now it does the CI of 0.3 down here. Now it moves it back up to 1, and it goes up to 9826. So we got 14 points out of that last iteration. But what this recipe will do is keep going through sets of 3 or whatever, you know, you put the step size at, until the last iteration of the last cycle of the previous step, going to the last cycle of this set gives no more than 1 point. So you can see here's step 3, it's 9812. We went up to 9826, which is certainly more than 1 point, so it's going to keep going. So seg 3. I will edit this down a little bit from here and make sure that to shorten the video a little bit so that you don't have to sit here and watch it, because it can take a little while to finish out going down to just getting 1 point, less than 1 point per cycle. You can see we got 12 points. We went from 9836 to 9848. Now we're up to 9851. You can see that on this step, it only got to 51.90, whereas the highest is 0.99. So it didn't quite get, oh, there, gained another 0.4 of a point. So it's going to keep going. Well, we'll see. So this is the one that we'll look at to see whether it stops after these next three. I'm going to stop it here just to reduce the amount of time that we spend recording the small improvements that it's making. The next recipe that I run, what we're doing is trying to make the protein relax in this configuration. So what we did was wiggle it, and until the wiggling didn't gain us too many more points. Now there's another program called Micro Idealize, and what it does is goes through and every interval where you can set the interval. Here, let me show you that. Idealized length. It takes that and I set it down to 1, so it'll do 1 by 1. It'll put in a cut, wiggle, heal the cut, go on to the next one. Cut, wiggle just the one, heal the cut. So let's go through and see what it does. So you can see there, did you see that cut there? So it did number 2, then it does 72, 71. You can see there it made an improvement from 53 to 67. So that segment 71, had some strain in it, and it's now less strained, and so we get a higher score. So this one will go through all of the segments one by one. When you select a length bigger than 1, what it does is it starts at the 1, and then it does 3 segments, and then a cut, and it wiggles those 3, and then it'll still go 1 by 1, goes to the next one, takes the next 3, puts a cut, wiggles those 3, and so on. So what I found is that you can do by 3s, and then if you do by 1s, you'll pick up some more. Also, if you do by 1s and then run it by 1s again, sometimes you'll pick up a few more points. Because if you relax one of these guys and he's been putting strain on his neighbor, then you may be able to go back and then relax some of the strain out of this guy. Now that this guy is not putting the strain on him himself. So again, I'll not put you through watching the whole thing running end to end. I'll tell you where we end up. We're currently at 98.78, and we'll see where we end up. There's some recipes that have a finite run length where, for instance, on this one, it'll go through segment by segment, but once it reaches the end, then it quits. Other recipes are set to loop indefinitely. those ones you can start running and then go off and do something else, you know, watch TV, do whatever, um, do the dishes. Yeah, you can, these ones I like to sit and watch just so that I can minimize the time between when it finishes and when I start the next one. So you can, if you take a look at the protein now from the end view, you can see it looks like we've got our one set of sheets there, one set of sheets there, a couple of loops to in the couple of helices, small helices in the loops that are connecting those, and that's part of what closes off this end of it. On this end, we have this thing sticking out. We'll see what happens to that guy in the fold, whether he actually ends up sticking out like that, and maybe that's the active region of it or not. One thing you'll learn after you do this a while is to know the names of all 20 of the amino acids that are in a puzzle like this. Um, you can see like this one's a phenylalanine. There's another one here. This is an arginine. You can see that. There's a couple of those there. The orange ones are the hydrophobic ones, so they want to be on the inside, away from the water that's surrounding this. This is a hydrophilic, the blues. They want to be on the outside because they like being in the water. So one of the things I do is I scan around and I look, to see this guy has a couple of blues on either side of him, so they're going to help protect him from the water. Same thing here. Some of these guys don't mind too much being in the water. The orange ones, this proline here, he doesn't mind being too close to the water. If he's the only exposed that you've got, the only one that's exposed to the water, then you're in pretty good shape. Here we've got a methionine and so on. So another methionine, valine. All right, proline. Prolines want to be kind of at the begin or end of helices and sheets. So you can see here that it's at the start of this kind of mini helix. So we're almost done. We're got at 72 out of 88. And you can see one of the ways you can tell the improvement you're making is first the score or the color. The darker green it is, the better. You can see there's still some things that have a little bit of score improvement that they could have with the brown ones. So those are the ones we'll kind of look at a little bit as we go along. So we're at 98, 91. This one's a fairly straightforward one. We could tell just from looking at the initial condition kind of what form it wanted to be in once it got worked over a little bit. You could see this band of sheets and then this, or excuse me, this sheet and this sheet. I guess these are called strands and these are called sheets. So we're almost done. Okay. So just from those simple little steps right there, we've gone from basically nothing to almost 10,000 points, 9,892 points. and you can see that it didn't take too long. Okay, and then my usual next step, yeah, I kind of have a formula in my head of which ones I use, is this recipe called QuakeR. What that does, what QuakeR does is it picks some bands, and it'll tell you which ones it's going to pick, and basically squeezes the protein and then lets go and wiggles and sees if it can get any points just by squeezing and trying to get it to move a little closer together. So you can see here what it does basically is it takes 1% of whatever the current score is, pulls until it loses at least that amount of points, and then it stabilizes by doing what's called a fuse, where it moves the clashing importance down, wiggles, moves it back up, wiggles. And what it's trying to do is get the score to within a small amount of this guy before it goes on to the next stage. Here it gained another 64 points. And then it goes into what it calls fusing. And fusing, you can see here, it moves the clashing importance down, moves it up, wiggling at each of those different sets. So down, up, down, up. It wiggles, it's wiggling all. Yeah, it just does a wiggle at each of those different points. So, oh, you got another 4 points. So now we're at, well, it doesn't give you the current score, but we could add it, 68. Added to this puts us at 99.60. And now another 11, 99.71. And so on. And so we can wait until this thing stops getting us more scores. It's at 99.83. It'll do the fuse just with that one pull. It'll do that several times, 5 or 6 times. I'm not sure exactly how many, but it'll do that until it decides that it's pretty well exhausted the capacity to get points. And then it'll move on and put the bands in a different place. You can see here on this first one, bands from segment 7 of length 20 every 39 segments. So it started at 7, and it put a band every 39. So it did it at 7, started at 7, and it went to 46. And then whatever 39 more than 46 is 70, if there's that many in here. So it just did a couple of bands, did the poll, and now it's wiggling to try to get more points. So let's bring this down. Oh, see it here. It stabilized, and it didn't get it close enough. So it went on. Here it's trying to stabilize. 90, we're at 99.83. You can see that right here in the current score after that pass. So I look at it, and I let that one run until it does 3 or 4 passes in a row with no gain in the score. And at that point, it's pretty well exhausted my patience, if nothing else. It's the recipe, if you let it run, will go to 50 passes, but once you get 3 or 4 in a row, it's going to be pretty marginal how many it gets from there. So there you can see it's getting pretty compact in there. The oranges are getting pretty well buried inside there. The blues are all over the outside. So let's see, this one didn't get any on pass 2. No, it didn't. 2, 3. If it doesn't get anything here, I think we'll stop it, move on. Fusing, well, I got it close. 9983. Yeah, we got 1 point. Okay, yeah, let's just stop it there and move on. Now let's go back to that one sheet that I looked at earlier, where you can see we've got this phenylalanine pointing at this guy. It might be that that's what's causing this twist right here. So what we can do is click out here, and then let's just select these few sheets right here and pull this guy up straight. And while we're doing that, let's also go under here and pull this guy to the side and see if we can't twist that back. Oh, that worked pretty good. You see, now we did that. Okay. And now we can look at possibly mating him up with this guy. So let's see if we can pull these guys together a little better. Okay, wiggle. Okay, we got another band there and another H bond there. So we did manage to connect those. That'll give us, each H bond gives us about 10. So you can see we went from 9989 to over 10,000. So let's hit R to remove the bands. And that's where we're at. Okay. Okay. Let's stop the wiggle. And is there anything else that's obvious? No, nothing else that jumps out at me. The next thing I like to do is look at, oops, I don't want to pull on that. Look at these helices. You can see this guy's a little bit bent out of shape. Well, I guess we look at him head on. He's not too bad, but one recipe I like to run is one called helix twister cut. What that does is you give it the loop spacer. What that is how many segments there are between that helix and the other elements that it's connected to. So 1, 2, 3. Yeah, it's got more than 3. This one has 1, 2. So let's put this guy down to 2. And let's really put the loss up there. You can see it's identified the 3 helices that we've got. We want it to start by twisting them clockwise, and let's go. So you can see here what it does is it puts a band on each segment that's at a tangent to the axis of the helix. And so it's got one, this one was pulling this way, this one's pulling this way, this one's pulling. So what it's trying to do is twist it around the axis in that direction. And then what it does is once it's twisted it enough where you told it how much to twist it by the band strength, then it wiggles to see, it lets it relaxes it by wiggling and checks the score to see if it improved any or not. And you can see there, oh, look, that one, we managed to get a little more. We're up to 10,057. So that's looking pretty good. It's pretty tight in there. Things are starting to really get close to one another. All the sheets have good H bonds between them, multiple H bonds, about as many as they can get, I think. If we look, yeah, there's Yeah, that one looks pretty good. That one looks pretty good. So even here, where there isn't really a sheet, we've got a couple of H bonds to this loop here, and this this helix. So there we went up to 10,083. So we kind of, again, we relaxed the whole thing. We pulled together the elements that look like they want to be together. We did, used some bands to pull them together, and then we ran some routine, the Quaker routine, and what it did is to try to squeeze it down like a Brillo pad, it's squeezing it down. And then now we ran. What else did we run? I guess that was it. So notice that we're still on low wiggle power. So we got up to 10,000 points, over 10,000 points on low wiggle power. Low wiggle power gives you it's less strict about making sure that everything's in the right, everything is ideal in the backbone and in the side chain and the connections. So you can see if you hover over low, it says no ideality computations during the wiggle. Medium says it looks at the backbone ideality, and high says it runs every ideality computation it can think of. So no ideality. It just says, let's just pull them around and see what happens. So now we want to be a little more rigorous once we've gone through here. I do this until it's gone through the 1 or 2 cycles, complete cycles, 1A to 1A, without getting any more improvement, because at that point it's gone through each of the helices, twisted them one way, twisted them the other, didn't get any improvement in either direction, and gone on to the next one, didn't get improvement there. So now it's just trying again. So let's go ahead and stop that. It looks like it's gotten what it's going to get. So now we're looking pretty good. We're at 10,000. So another one we can run at this point, now that we've wiggled it around and straightened out that one sheet, that one strand, we can run another one that I like to run called Jet. Jet is a program that you can run that basically just it goes through, and first it does every other one. It selects it, wiggles it, selects it, wiggles it, and you can see this is a lot slower than the cut and wiggle everything, but it's very thorough. It goes through one by one and tries to get more points. That's what I would call more of a mid to end game type of recipe. You can see we are getting more points. We're up to 10,084, but it doesn't get us points very quickly. So let's go and cancel that. The last one that I like to do before I play around with the wiggle power is one called AFK3, which has a bunch of different things. I give it 1,000 chances to fail. I don't discard anything, and I say shake. So what it's going to do is get the clashing importance down low at kind of a random value, wiggle it until it stops wiggling, and then shake, which will rearrange the side chains, and then it moves it up, does a shake, does a wiggle, so it's in the middle of a shake. So this is a little more involved method of fusing, what they call fusing. fusing is the principle of reducing the clashing importance while you wiggle and then moving it back up. Simple fusing is where you just do move it down, wiggle until it stops, move it up, wiggle until it stops. If you shake the side chains at those points where you stop, see where it went down, now it's in the midpoint, then it'll move up and shake. You can sometimes convince the various elements to move their positions and get you some more points. So now we're up to 10,099. You can see we got 14 points on that first try. And then we got another half a point at the second try. So let's look at it a little more closely. Sorry about that. My Apple Watch. But we got another almost a point. So we're at 10,100 at this point. You can see that as we get the score up higher and higher, the protein is approaching its minimum. So it gets, as they get closer and closer to kind of the minimum value possible, it's going to get harder and harder to get those last few points out of it, or get that last energy out of it. We got 2 points now, 2.8. So, but you can see, before where we were getting 50 and 60 points, now we're getting 1 and 2. One of the things you'll discover as you play this game is that it does take patience, to try various things, to watch, to run the recipes, to do hand folding. You could see when I did the bands between each of the segments, it takes a little bit of time to do each one like that. I guess you could write a recipe to do that, but that would be interesting to do. So you're making sure that you had it positioned right and everything. So you can see now we're up to 1,113. So we've got 15 points now without a failure. So it's gone down and up. Got some points, down and up, got some points, down and up, got some points. You can see here, this is the number of failures that are remaining before it stops. I set it to a really large value so I can watch it and let it run. And when I'm tired of, when it stops getting points and it's going through and just not getting points, then at that point, I'll cancel it and switch to a different way of massaging the protein. Okay, so you can see that. Now you can see, we've done all this with the wiggle power on low, so that's not where we get the most number of points. But that gives us the ability to more easily move things around and get them lined up and get them to where they're liking one another and working together to get us points. You can see what I like to do every now and then is look through these aromatic rings. These are called aromatics. And you can see that it's trying to line this guy up kind of with the shape of the aromatics. The aromatics, they either like to be parallel to one another or they like to be perpendicular to each other. So these two are perpendicular. Okay, you can see these two, they're perpendicular. This one's perpendicular to this guy. This one The proline kind of forms a miniature aromatic, and you can see that it gets lined up with this tyrosine. So there's that, and then we have this guy that's kind of perpendicular to that one. The methionines like to, let's see if we can get one here, like to also try to mimic the curve of the aromatics, like that. So tyrosines aren't so picky about being on the outside. They can stand being exposed to the water a little more than the rest of these guys, orange guys. And one of the things they can do here is make these H bonds so that they kind of form a barrier to the water getting in there. Okay, there's 116. So we're accumulating points. We still haven't run out of. We haven't even failed once as we do this process. But at this, we've almost reached what I call the end game, kind of in the mid game where we have the basic shape, and what we're doing is kind of getting it into its optimal position with wiggle power on low. Well, this is kind of boring. I get tired of watching these things or get impatient. So once this starts getting failures, on the cycles, if it gets several 8 or 9 in a row before it gets another set of points, I will cancel it and go on to the next phase. The last phase is going to the high wiggle power. Now, at that point, what you're going to do is run all those ideality calculations, and what that's going to do is look at each one of these segments and kind of try to improve it. So let's do our cut and wiggle again, because he goes through 3 at a time. He goes on 3 at a time, and we'll do the ideality calculations on that. So we start at the 10,119. We're going through it again, and you can see that it's going to end up around 10,400. What I've seen in the past is that when you go from low to high, you'll gain about 300 points just by going through that and improving the ideality of the various pieces. So actually, we went to 500 some odd. So 119 to 500, 519, 546. Ooh, 119 to 600. So we got almost 500 points out of that just by applying the high wiggle power, all those ideality calculations while it's doing the wiggle. 687, that's not bad. So you can see that was quite the jump from 119 to 687. And look at that methionine trying to match this guy's circle. $675. Looks like it's not going to get a lot more than that. Let's see what it comes out here on this next one. Next cycle. Sorry, it keeps. My mouse makes it kind of gradually move away. Or it must be the way I hold it. 687, and then it gets us up to 97, 99, 700. Okay, so we got another 13 points there. Let's let it go one more cycle and see what it does. One more try. So what I'm going to do is go through essentially the same sequence that I ran through at low wiggle power, applying the different recipes, you know, that are aimed at getting the best shape, relaxing it from its distorted shape in the beginning. Um, Here, what we're doing is getting it into a more ideal shape from where it was. Let's move this down. See, we got another 11 points there. So we can let that run for a while if we want, or we can get impatient like I normally do and stop it early. See what we get this time. Mm, 11 to 18. So we get 7 points out of it. Okay, why don't we stop it there? I think you get the drift. And then I run micro idealize again as my next step, just like I did in the beginning at low. Now I'm going to go through and run it again with high wiggle power. So you can see we went from 18 to 718 to 722, 726. So now it's going through one by one. Or actually, I guess I did it with 3 at a time, idealizing 3 at a time, and seeing if it can make some improvement in those 3. $7.29. Oops, I got to remember to pull this guy down so we can see the progress. Okay, so there we are at 731. You can see it. It didn't get any improvement here on these segments, 62 and 63, 64, 6, 7, 8. You know, and what you'll see is that it won't get points on all of them necessarily. Some of them got into a pretty good position to begin with. And now what we're doing is just seeing, if there's anything that could be improved. And sometimes, a lot of the time, there's not. So let's see. I'm not going to run through that whole thing again. You can see we're getting some points, but I think that's the most of them. At that point, it's fractions of a point per run. So now let's go back and run our recipe Quake R, and see if that gives us some points. Again, the same sequence, shake, wiggle, shake, wiggle. In this case, we skipped that part. Cut and wiggle, and then micro idealize, and now we're doing Quake R. And once we get the bulk of the points out of the way, then we approach the end game, and that's a lot slower process. You could, there's some recipes you can run that will get you fractions of a point, thousandths of a point per run, but you know they run forever, and at some point the puzzle cuts off and you're left with whatever you're at. So here we are, 713. Yeah, we're not going to get much from this one. Nope. Okay, so we've gotten what we can. One other recipe that's good, at least in the beginning, is if you have some loops that after you do the cut and wiggle and the micro idealize and see that they're still red, you can run this recipe called fracture that will go through and try to rebuild the various parts of it. So let's tell it to go in the in game, which is fast and loose, and watch what it does. See there, it's rebuilding that one. Tries several different rebuilds, picks the one that scores the best, and then wiggles it. So you can see that took us from 731 to 800 almost. 60 points. That's not bad. And what it did was it made this guy green, and these guys are still brown, so there might be still some points in there. 66 points. Now it's doing the fuse thing again. You can see here the clashing importance is going down, and then it'll bring it back up again. And see, it's just one way to see if you can get a few more points. Oops, 770, so it's at 790, 97. Oh, look at that, 800. So, and then once you've gone through and done all that, sometimes I go through and I look at it, and like these couple of guys here, these couple of segments, they're still brown. I try pushing, let's see, where is it down here? The 5 key. Idealize the secondary structure and see if that gets me any points. Oop, that took me down. Okay, but let's see if we wiggle. We were at 802, we're at 786, 7. No, that didn't help. Okay, so let's stop wiggling and then go. I use the if we go to the undo menu, we can restore the credit vest. It'll take us back up to that 802. So I don't see anything where we can really improve a lot manually. So in the end game, where you're looking for a point here and a point there, the best program recipe that I've found to use is to put the wiggle power down to low, and there's one called banded worm pairs infinite. And what that does, just say run, it goes through and it does pairs of length 2, and it applies bands to it. And I guess we missed it. There it is. See the band right there? And pulls it around, pulls the side chains around to see if when they relax, they'll be in a better position. So now it tries it from a different place. And we went from, let's see, we started at 802, now we're at 813. So band 1, it got some improvement. You can see here on segment 3, it got a very small, a 40th of a point. And what you're doing at the end game is just looking for, all of the 40th of a point, 20ths of a point, thousandths of a point. Sometimes is all it takes to get slightly better. So I hope this helped. I'm going to stop it here. That gets pretty boring. And what I normally do is I put it on low, run it overnight, and then when you come back, you put it on high, and you run AFK3, and you see, okay, now that I think of banded worm pair as kind of loosening it up, getting a point here, a point there, and kind of shaking out all the tight points. And then what you do is you come in and do this, a fuse, to see if you can minimize the shape and reduce the energy, which gives you the better score. So we were at 813, now we go to 814. So we got a little bit, but we didn't run banded word pairs for very long. So that's how I get the points. And that's how you can approach it. Anything else I can tell you at this point? I think that's enough for now. That'll get you started and get you right up there with all the rest of us that have been around a while. Thanks. Thanks for listening, and hope you like playing Foldit.